Okay, we move on to question 7, which dealt with a graphs question, trigonometric function. Let's see what they say. They say in the graph, the graph of g of x equals a cos bx is sketched on the axis below. Domain from minus 90 to 90. Now please folks, you need to notice that this is bx, so this indicates there's going to be a period change. And this here represents your amplitude. There could be a change, there doesn't have to be a change, but A represents your amplitude. Let's see. Well, here they ask you, write down the period of G. Now what you're thinking is what I'm going to write in green. The period for cosine of theta, that period, folks, is 360 degrees. The very first 0 for cosine usually starts at 1 and goes to 90, but it's going to 30. So it's going to 90 divided by 3, which is 30. Okay, so if everything in terms of theta is divided by 3, then finally your period is going to be 360 what it was divided by 3. Which is 120 degrees. This is your period for 1 mark. Okay, that's a quick one. Now they ask you for the amplitude, and actually, what is this value of b? Now, we've already established the value of b. The value of b is 3. Remember, if you multiply in the equation, you divide when you do your calculation. If you divide in the equation, you multiply when you do calculations. And when we do the calculation, we divide it by 3. But let's see how we write this out. A is the amplitude for cosine. Now you know your normal cosine graph would go to that's the sine graph. Your cosine graph will start there, go through and go to minus 1. So 1 and minus 1. The cosine graph still does that. So there's no change in amplitude. A is still 1. The amplitude is still 1. Now remember, what is an amplitude? It's the maximum distance away from the horizontal. The horizontal in this case is the x-axis. It goes 1 this way, 1 that way, perfectly symmetrical, nothing changed. Now for b, the value of b. So we can say that bx, in this case, we're going to say is equal to 30. Now what was x? X is usually 90 over here. Okay, so if we look at your first 0, and your 0 is now at 30. So if we look at what happened to 90, your bx is usually 90. Sorry, there, your x value. Now with the change, bx has gone to 30. So if we let x equal 30, we get 30b is 90. So b indeed has to be 3. Now you don't, whichever way you think about this, folks, is how you're going to reason here. I just like the fact to check where it was, where is it now. It makes no sense to compare naught, because naught divided by anything other than naught still remains naught. So I need to look at the other zeros and compare them. It's usually at 90. It's now at 30. So it has divided by 3. So in the equation I times with 3. Okay, there we go. So this again is what you're thinking, and your final solutions or your final answers will be those two. Now the last part of this question is asking us, let me just zoom out here, is asking us to sketch this function on the same set of axes. Now we're going to start by sketching the mother curve for sine. I'm just going to draw dotted lines here so my pen doesn't go skew. Sine would usually go through that point, this point, and that point. It goes from 0 to 90 or minus 90 to 0 on this side. What happened? We minused 30. Now remember, you do the opposite. On the graph, you're going to add 30. So this critical point will move there. This critical point will move there. And that one will move outside somewhere over there. So if I now want to find my y-intercept here. So y-intercept is where x is 0. So it's the sign of minus 30. Okay? What is the sign of minus 30? Well, minus 30 is in the fourth quadrant, so sign is negative. So this is minus sine 30, and I know the sine of 30 is a half. So it's going to go through that y-intercept there. Okay, so if I now draw in pink, basically, now I'm going to aim for that point, and I'm going to stop when it reaches the end of the domain. This one's going to bounce back and go up and finish over there. How do I find that coordinate pair? Well, I go to the equation sine x, and I make x 90. So I get the sine of 90 minus 30, which is nothing else. 90 minus 30 is 60. The sine of 60 is root 3 over 2. So that there's the point 90 and root 3 over 2, and this will be minus 90 and minus root 3 over 2, where it enters the domain. So folks, there was nothing spectacularly difficult about this question. It was a nice, easy question. If you know your work well, you would have gotten 100% for this particular question. Just remember, if the change is with the horizontal values, you do the opposite than what the equation suggests.